Hello everyone. It is 2 a.m. as I'm recording this. My hair are longer than they were in the previous video. It has been some time since I have been in front of the camera and my hair are a little more unruly as well. But that should not distract you from the fact that we're about to solve a problem that is very, very basic, very popular, but very simple and very interesting. Problem is longest palindromic substring. The name itself is quite self-explanatory. It has three keywords: longest, palindromic, and substring. So, what is a substring? I've explained this in one of the previous videos, I think. Substring is simply a part of a string. It could be a single character, it could be multiple characters, it could be the entire string itself. That is your substring. Palindrome. What does a palindrome mean? A palindrome is a string that is the same when it is read from the front or from the back. For example, B, it is a palindrome. AA, it is a palindrome. ABA is also a palindrome. ABB is also a palindrome. Or something more interesting like a race car, if you're into Formula One, that is also a palindrome because it is read in the same way from the front and the back, which basically means that the first character is the same as the last character. The second character is the same as the second last character. Same goes for the third character, so on and so forth. That is a palindrome. And we have to find the longest palindromic substring. Alright. So let's get to it without further ado. So let's take an example. Let's take the one given to us over here, BABAD, and work with it. Now, I have two approaches for you in this video. One is the brute force approach, and the second one is, well, I won't tell you the second one just yet. We'll get to it when we get to it. The brute force approach is simply where we check all the substrings. We check whether each substring is a palindrome or not. And if it is a palindrome, is it the longest palindrome? So what could be the possible substrings of BABAD? So all the substrings that start with, say, the character B, they would be something like B, BA, BAB, BABA, BABAD. Right, that's the first set of substrings. Then all substrings starting with the character A would be A, AB, ABA, ABAD. Similarly, all the substrings starting with the character B. And you get the drill by this point. So I'll just write all the others down. Right. Now, out of all these, I have to find out the ones that are palindromic. And of course, I have to return the one that is longest out of all of them. So let's see which ones are palindromes. BAB, ABA, and of course the single characters, they are also considered as palindromes. And I think that's pretty much it. Those are all the palindromes we have, and the longest that we have are two actually, BAB and ABA. So which one do we return? Well, that has been clarified for us over here. The output is BAB, but ABA is also a valid answer as it should be. So that is the brute force approach. And if you don't know how to check all the substrings, I'll point you to a resource in the description below. And just to give you a brief on how to calculate substrings, what you do is you take two loops. Loop 1, or I can just write a simple for loop just to give you an idea. The way I prefer to do it is I start from the very end, right? Let's say R for right pointer is equal to the strings length minus 1. I go all the way till 0, r minus minus. And the inner loop will be something like the left pointer that will start from 0 always. And it will go all the way till r, because r is our right limit, right, for the substring. And we simply get the substring between these indexes. So that would look something like, for example, if our string is ABC, so we start at R over here and L over here. In the very beginning, we will get the substring as ABC when L is 0 and R is 0, 1, and 2, right? That's the index. R is 2, L is 0, we get ABC. Then L goes to 1, right? L will increase. Then we get BC as our substring. Then L will become equal to R and we get C as our substring. Then R will decrement by 1. So R will move to D over here, in which case L will start from 0 again. We get AB as our substring and then simply B as our substring. Lastly, R becomes 0th index and L of course starts from 0. So we only get A as our substring because L cannot go beyond R. So that is basically how you can get the substrings. And for each substring, you check whether it is a palindrome or not, for which I can either point you to a resource or maybe I can just put out a separate video for you all. And if I do, I will definitely link it in the description below. So that is the brute force approach. Now, let's calculate the complexity of such an approach. So to calculate the substrings, you can see that there are two loops being followed and these go through all the characters of the string. So we have an n squared complexity by itself. But like I said, not only do we get all the substrings of a string, we also check whether each substring is a palindrome. And a palindrome is calculated basically by taking two pointers and checking whether the characters at each pointer are same or not. So for example, I'll take a better example for you. Let's say A, B, B, A, right? We take two pointers. This is a crash course on how to calculate palindromes. This is not the complete solution. Of course, I suggest that you go in depth because it is very, very fundamental for you to do so. But to put it very, very simply, we get two pointers left and right. We check whether the characters on both pointers are the same or not. If they are, then we simply move the pointers. We simply move the pointers to the next character. So we check the second character with the second last character over here. And whenever L and R crossways, when they either are on the same index or whether they cross each other, we simply say that this is a palindrome. Or if at any point we encounter two characters that are not the same, for example, if this was a D, right, or a Z, or a Z, however you pronounce it, it's completely up to you. We simply say that that's not a palindrome. So that's basically how we check a palindrome. And if you notice that we go over all the characters in a string exactly once, or it could be less, but at worst we would check all the characters of the string at least once, and that complexity will be big O of n. So the total complexity, time complexity to be specific, becomes big O of n cube, and the space complexity becomes big O of 1 because we don't really allocate any extra space, which is a good thing, but the time complexity is not exactly the best there is. So we move to our next approach. Our next approach is what I'd like to call the expanding centers approach. It's a pretty heavy duty name. So let me do you the favor of explaining exactly what I mean by it. Again, two keywords, expanding and centers. Let's start with the second one. I say that whenever we have a string that string could be something like D A B B A. Okay, something like this. I say that at any point, take a center in the form of a character, or maybe even multiple characters. We'll see what I mean by that. But let's, for the sake of simplicity, assume that I mean a single character over here. We take a center, we expand in either direction, and keep checking whether, as we expand, whether the characters that we find on expanding are the same or not. So that's one example. I'll also take another example to give you a better idea. Of course, I will go over this example. Don't worry. It's not that I'm leaving this example for this other one. It is just to prove a point, which you will understand in a minute. So let's say we have a center over here, all right, at this factor B. I say that, okay, first you check whether this is a palindrome or not. It is. So you expand on the left and on the right. You check the characters over here. Are they equal? If they are, then of course this is a palindrome that we already had. After expanding, we find another palindrome because their characters are equal. This could be our updated answer. But you know what? We will be ambitious. We will check even further. We check again. And we see that, okay, you know what? We are getting an even bigger palindrome. And we keep doing so till either we reach the very foundations of the string, or till we reach a case where there we encounter characters that are not equal, so as to not form a palindrome. So that is the expanding centers approach. So now you would be asking, okay, if this example seems good enough, it's simple enough. We have a center, we're expanding, and we're looking for palindromes in this way. Why did we take this example? It is because you've noticed that the length of the palindromes in this case is 1, 3, 5. And if the two characters were equal, it would have been 7. And of course, it's not necessary that there would certainly be a character here. It could also be nothing over here. In which case, whenever we reach the end of the string, we will simply exit the process. Now, anyway, back to the point. These lengths, you would notice, are odd in number. So not only do we need to take care of odd numbered cases, we also need to take care of palindromes that could be even in length. So how do we do that? We focus on this example for that. I say that you take a center that consists of two characters instead of one, like one character and the character after it, and you check whether these two characters are equal. If they are, great, you expand even further, right? Of course, you'll take 2 pointers for this, pointer 1, pointer 2. You move the pointers to the left and to the right. You check whether these two characters are equal. If they are, great. If they're not, no problem, you exit. But in this case, they are. So we go to the left and we try to go to the right. We see that, okay, we have something on the left, but nothing on the right. So we simply return this as our longest palindromic substring for this particular center. Of course, this is not the only center we'll be taking care of. We'll be exploring all the centers in this string, which I will dry run in a minute. In this case, I'll simply return the substring. Then whether it is an even case, whether it is an odd case, it doesn't matter. We will check whether this substring that we have, substring, this will certainly be a palindrome, as we've ensured, and we will also ensure whether it is the longest or not. If it is, we update our answer. If it is not, we will simply move on to the next center, right? Now, to actually give you an idea of how this works, let's take the example given to us on the platform itself, BABAD. So, as I mentioned, we have two approaches over here. First, we check for odd, right? Let's call this function the expand function. that will expand over our center by taking our two pointers as an input, right? It will take pointer I and pointer J as an input. What it will do is it will take I, take J, compare the characters at I and J. If they're equal, it will move I to the left, it will move J to the right, and it will check again and again till we either run out of palindromes or run out of the string itself. So this expand function is doing exactly that for us. And one case is for the odd palindrome, odd length palindromes. The other is for even length palindromes, right? So what is the difference between these two function calls? Well, we will dig into that right now. So what we have to do while defining our centers is we have to start off with a simple loop, okay? Where your I will start from 0. I will go on till right before the length of the string, and it will increment by 1 every single time. So what will happen is that at any point, what we'll do is we will have a certain character with us, which will be at the index I. What we'll say is that in this case, in our odd case, you expand with both the pointers starting from index I itself. So we will start from B and expand from there. So in this case, for example, we'll go inside the expand function. We will check whether this is a palindrome. If it is, okay, great. We will try expanding on either side. But there is nothing on the left. So basically our basic conditions are simple, right? Either the left pointer should be greater than or equal to 0. The right pointer should be less than the length of the string. And of course, the characters at the left pointer and the right pointer should be equal. These are the basic conditions that we have to check while expanding. So this is what we'll be using. So here, indexes are 0, 1, 2, 3, and 4. Okay, B is a palindrome. We got that. But before expanding, we check again. Okay, we decrement I and J, right? I started at 0 in this case. I becomes -1, and this other I, sorry, it's yeah, okay. I and J, right? J becomes 1. Does our condition satisfy? Is the left pointer greater than 0? It is not, so we simply move out. And of course, these are all AND conditions, so all of them have to satisfy before we process it further. Because if they do work, we decrease the left pointer and we increment the right pointer. We exit with our substring. We return the substring itself, okay? So we get B as our answer in this case. Is B the longest palindromic substring that we have so far? The answer is actually yes. So let's maintain our answer over here. Its length is 1. The answer itself is B. Okay. But is that all we have to check? No, I said that we also need to take care of the even length palindromes. For that, what I'll simply do is have I as one of the points, that is the left pointer, and I plus 1 as my right pointer. Those are my two centers. And basically the left pointer in this case is at 0. The right pointer over here is at 1. Does our condition satisfy? Is L greater than or equal to 0? Yes, it is. And does the right pointer is it actually before the length of the string, which is in this case 5? Is 1 less than 5? Of course it is. Are the two characters equal? That is B and A. This is our center, right? Center is over here. Left side has B, right side has A. Are the two equal? No, they are not. So we do not go in there. We simply exit. And we don't return a substring because, well, the substring will be an empty string in that case, to handle the edge case. And we move forward to the next center, where I will then become 1, right? I will become 1. Our algorithm stays the exact same. I'll just put a closing bracket here. And if I is 1, for odd case, we put 1 and 1 as our input. Is L greater than 0? Yes, it is. Is R greater than the length of the string, that is 5? Yes, it is again. But are the two characters equal? Well, the two characters are the same pointer, right? Which is index 1. They are the same index. So, of course, they are. So, we move L to the left, R to the right. So, L becomes 0, R becomes 2. Now, we check. This is an important case. We check whether L is greater than 0, greater than or equal to 0, and whether R is less than the length. The answer is true in both cases. And is the character on the left pointer equal to the character on the right pointer? The answer is again yes. So we expand even further. L becomes -1 and R becomes 3. Now, does our set of conditions still satisfy? The answer is no, because L is not greater than 0 anymore. So we return the substring in such a manner that we have to start the substring from the character, as you can see, L plus 1, and we have to end right before this particular index. So that would make our answer as 2, R minus 1, sorry, R minus 1. And in this case, that would be 0 and 2. Okay, so the indexes, the substring that we have to return should start from index 0, it should end at index 2. That is B, A, and B. And if you notice, B, A, B is actually a palindrome. And not only is it a palindrome, it is the longest palindrome that we have encountered so far. In which case, of course, we have to update our answer. Of course, that code will be written somewhere over here. The length is now 3. The answer is now BAB. And after this, we shift our answer. So shift our center. Shift our center. Repeat the process. And you keep expanding. And in case we had another B over here, it would make a lot more sense to you if this even case was then found to satisfy, in which case the answer would be ABBA, right? So that is basically the expanding centers approach. And there is a reason we discussed these two approaches. I wanted to discuss the brute force approach first to build some intuition on how to solve this problem, but it wasn't the best approach as we discussed with respect to the time complexity. So what makes the time complexity of this approach better? I say that we have a few operations over here. The first operation, of course, is this loop. This loop takes big O of n as our complexity. Then what is the complexity of this expand function? This expand function starts from a center, goes all the way out, right? In the worst possible case, it will go all the way to the very ends of the strings. So it will test out all n characters, right? So that's for n into O of n again. And what is the what is the complexity of this even expansion function? Well, if you notice carefully, for each iteration that we have over here, in case of the odd expansions, we have n number of centers that we are testing on, that we are expanding on. That's 1, 2, 3, 4, 5, and 6. Actually, I did not take this initial b as my example, so let's just remove that. That makes our length to be 5 that I wrote over here. So we have n, 5 is equal to n, right? That's n. But in case of even centers, we take them 2 at a time, right? So there's BA as one of our centers, that's 1, AB as 2, BA as 3, AD as 4. That's n minus 1. That's n plus n minus 1. That is 2n minus 1. That is simply big O of n. So we perform this operation, that is big O of n in complexity, n times. That makes our time complexity to be big O of n square, and the space complexity remains big O of 1 because we don't allocate any extra space to solve this problem. And that is the approach that we follow to solve this particular problem, that is longest palindromic substrings. Of course, there are other solutions as well. You can use dynamic programming to solve this. You can use something called the Mannekers algorithm, Manachher. That's Mannekers algorithm. And that is even more optimized, but that is not something we're digging into today. This solution is good enough for the time being, and that is what we'll be implementing in the next video. So stay tuned and subscribe for more.